In most cases, the default 3D mesh provides an accurate representation of your model. This video explains how to decide if your model is better suited for a dual domain mesh instead of the default 3D mesh. There are two good reasons for selecting a dual domain mesh: analysis time and analysis sequence. Let's look at each of these in turn. Analysis time. Dual domain analysis are quicker to run than 3D analysis because they rely on more solver assumptions. However, to use a dual domain mesh, your model must be simple. A typical dual domain model is shell-like, with no rapid changes in thickness. Analysis sequence. Some analysis sequences are only available for dual domain meshes. If you need to run one of these analyses, then you'll need to generate a dual domain mesh on your model. Now, what is a simple model? What makes it suitable for a dual domain mesh? The width to thickness ratio is greater than 4:1 for all features of the part. For reference, a square cross-section has a ratio of 1:1. The few small features on the part that are not suitable for a dual domain analysis do not influence the overall flow or structure of the part. If you're still not sure if your model is suitable for dual domain, consider the following. If your model has chunky components, use a 3D mesh. For example, any of the following model features make your model better suited for a 3D mesh. Some regions of your model have a width to thickness ratio less than 4:1. 3D meshes represent the heat transfer in these small ratio regions more accurately. The model has many features with low width to thickness ratios. The thickness of the model features is significant compared to the nominal thickness of the model. The model has sudden changes in wall thickness. The analysis sequence you want to run is only supported for 3D meshes. In this video, we showed you how to decide whether to switch to a dual domain mesh or accept the default 3D settings. In most cases, the 3D mesh can be used.